Good morning to everyone out there. First, something about me. You are in the session Stretch Cluster Notes from the Field. My name is Carsten Rachfahl. I'm one of the Cloud and Data Center Management MVPs. In fact, for 11 years now, I got my 11th award some days ago, and I hadn't even the time to tweet and blog about it. And I'm also an Azure MVP now in the third year. I like to be in both categories. I always says cloud and data center management is the old on-premise world, and Azure is the new Microsoft world. And I'm between that, a bit more on-premise still than in Azure, but both. And then I'm also a Veeam guard. So why I'm doing this session? In the Azure Stack HCI implementations I'm doing, the stretched cluster is really the feature that most of the customers want, and if they don't do storage spaces direct, and do Azure Stack HCI, it's mainly because of the stretched cluster feature. Because in Germany, and I think it's the same for Austria and Switzerland, we use a lot of stretched clusters. Maybe if you look at the amount of people who live there, most stretched clusters in, how you call that, per head of people are maybe in Germany. So why use a stretched cluster? What are the reasons for a stretched cluster? Because it's more complex, of course, than a normal cluster or even standalone nodes. So the data in the VMs is today very valuable, and you can't lose hours of work or even minutes of work in some environments, and there are a lot of those. So we have companies today who have a 24/7, so they work the whole 24 hours, 7 days, so including Saturday and Sunday, and even some of them 365 days a year. I'm actually at a customer who has this requirement, where the IT has really to work 365 days, and you need really full availability. And a stretched cluster, or a stretched cluster can help with that. So we want to protect ourselves against local disasters. So a stretched cluster could be, if we think about, let's say, a natural catastrophe, like a volcano breaks out, like we have now in Las Palmas, or you have a thunderstorm or a hurricane, you have earthquakes and so on. So you have maybe a stretched cluster that is where the two sides are large. There is a large distance between both. But a stretched cluster is also if you have two rooms with one wall, and one of the room, you want to prepare that this room has no power or can burn or whatever. So a stretched cluster, the distance can be very small, two rooms, directly connected the rooms, or on the same campus, maybe 100 meter, 500 meter, but it can also be a very long distance. And you want to protect yourself against the total not availability of one of these sites. So if one site is hit, VMs starts on the other side. That's very important. It's not something where you have constantly replication of the VMs and the memory of the VMs. It's a replication of the data. So if a VM runs in site A, the data is also replicated to site B. And if you have a disaster in site A, the VMs can be started in site B. So you have a slight outage of your application, but it will be there maybe after some minutes, and that on the other side. So there are some requirements for a stretched cluster. We have to have at a minimum 4 nodes, 2 on each side. So the smallest Microsoft Azure Stack HCI stretched cluster has to have 4 nodes, not 2, 4 nodes, 2 on each side. We have to have a network between the sites that can constantly replicate the change, the churn. So if we have a long distance stretch cluster, we will see on the next slide an example from Microsoft where they have one site in London and one site in Paris. That's very far away. Then you have to have a connection between the two where you can constantly replicate your churn. And if you have VMs on one side that do a lot of writes, you have to get them to the other side. So with a 100 megabit internet connection, I think that will not help you. You have to have gigabit or even 10 gigabit, and that's something that is not so easy, especially in long distance stretched clusters. On a campus, shouldn't be a problem to have 10 gigabit between the two sites. Then what's very important is the witness placement. We have to have a third site or Azure. I will talk about the witness placement a little bit later because this is really important. We have 4 nodes, and 4 nodes are an equal number of nodes. So the cluster must have a witness, and the witness can't be in the first site or in the second site. This is very important, and many stretched cluster projects don't have this third site or don't have the right connection to Azure. Azure is also an option you can choose. And then Azure Stack HCI is an Azure product, but you have to have it, every host has to be integrated in an Active Directory. And I'm not talking about Azure Active Directory, I'm talking about the old Active Directory. That can be on premises, of course. It can be hosted in VMs in the cloud, but the nodes have to be in an Active Directory. For example, today for the live migration, moving one VM from one node to another, you need tickets from the Active Directory, and that is a must today. Otherwise, you can't live migrate. So here is an example of Microsoft. Microsoft always thinks big because the Azure data centers, so when you have your redundancy, they are, I think, at least 300 miles apart. So the London-Paris example is something Microsoft thinks of. The cluster is stretched over a large distance, but that is not the requirement. You can also have one room. London could be and the name of one of your sites, so the room is called London, and the other room on the same campus can also be called Paris. But we can also have a cluster stretch over both cities, both European cities. Yeah. So when we have this cluster, we have VMs running in the London part, and these 2 nodes, we have a storage pool where these VMs live. So their data is spread over these 2 nodes. Yeah, and then when we create a replication, a replicated volume, every data that one of those VMs is written to the CSV, so the cluster shared volume, is replicated synchronously or with such a distance asynchronously to the other side, and then we write it here in a volume that is it's offline, it's not accessible, so it's but when a disaster hits, this volume will be brought online. So if we have an outage here in London, for example, fire or power loss, these 2 nodes here, because this is one cluster, so we have one cluster stretched over 2 sites, these 2 nodes will notice that the other nodes are not available over the heartbeat, and then they will bring up the CSV where the data is and start the VMs that are in these CSV. Yeah, this looks a bit like an active passive design. That's one of the possibilities, but more often we have an active design. So we have other VMs running on this side in another volume. This volume can also be stretched to this side, and then if this side fails, the VMs that were running here will be started here. So it can be an active or an active passive construct. So normally I would have here an 8-minute demo how to install an Azure Stack HCI stretched cluster. In the next session, Manfred will show that in detail. I will only show you the important part, what's different with a stretched cluster to a normal cluster that will Manfred show. So what you see is Windows Admin Center, and in Windows Admin Center, this is the actual one, the 21.03.2. We can add here under add. I will do that very soon. We can add a cluster, and I do that now. Add, and then we have create new server cluster. There are other possibilities we have, and then we have the possibility to install a Windows cluster or an Azure Stack HCI. And here you see we have all servers are in one side or servers in two sides. And that's the difference we have when you see Manfred's demo soon. Let's stop here. There he will not choose two sides. He will install the two nodes in one side. So, and then everything is the same until minute 6 here, after the cluster creation. Yeah. And then here in minute 6, when we continue here, after the cluster creation, because we chose two sides at the beginning, we have to assign after the cluster creation two names for the sides. Here I choose East and West, that are the two sides. And then we have to assign the nodes to the individual sides. So 2 nodes are added to East and 2 nodes are added to West. And then in the storage part that you will see in Manfred's section, it will create a storage pool inside A and a storage pool inside B. And that's the only time, as far as I know, where we can have more than one storage pool in a Azure Stack HCI cluster, and Storage Bases Direct does not support 2 pools. So I go back to my presentation and continue with the possible designs we talked a little bit about already. So we have 2 possible designs. We have an active-passive design. So we have a stretched cluster over 2 sides. We have side 1 and side 2, and 2 servers minimum in side 1, 2 servers in side 2. And we have all our active volumes, our stretched volumes inside 1, and they are replicated with storage replication to side 2, but here they are offline, and we have only VMs running inside 1. So these blue and red, not really blue, it's purple also, they are running inside 1, and side 2 is passive, so it's just waiting that side 1 fails, and then it will bring up the volumes automatically and also start the VMs. But most of the time, to be honest, I have never installed at a customer side an active-passive design. They always, so far, they always have active designs. So in an active design, we have one stretched volume here that is replicated from side 1 to side 2, and we have one active volume here from side 2 replicating to side 1. And of course, in one volumes are actively VMs running, and on the other hosts are also actively VMs running. And now each side is watching over the other side. If there is a failure, then the volume from the side that fails will be brought online on the other side, and the VMs are started. And of course, you can have multiple volumes. You don't have to have one volume on one side and one volume on the other side. There can be multiple stretched volumes on each side. And we can have also the possibility in a stretched Azure Stack HCI cluster, you will see that in the demo later, to create a volume that is only presented on one side. It must not be stretched. You can also have volumes that are only presented on one side. For example, if you have applications that have redundancy built in the application, like an Exchange DAG, so a DAG, or an SQL, how it's called, always on cluster, they have already redundancy in the application. So you put the VMs in a volume that is only represented on one side and another VM in a volume that is only represented on that side, and then you use the in-application replication. So stretched Azure Stack HCI possible nodes in two sides. We already learned we can have 4 nodes, so 2 nodes in each side. Here in this picture, we have a site in Frankfurt and a site in Hanau that are 2 German cities that are not so far away, let's say maybe 20 kilometers or 15 kilometers. So we can do that. And of course, you can have a 6-node cluster, 3 nodes in each side. And you can have an 8-node cluster, 4 node in each side. And you can have 10 node, 12 node, 14 node, 16 node, and then 5 node, 6 node, 7 node, 8 node in each side. What you can't do is a 2-node cluster stretched or a 3-node cluster stretched, or having an odd number of nodes. So you can't do a 7-node cluster, 3 in one side and 4 in the other side. They are always the same number of nodes in both sides. And if you look at this, we have also always an even number. So we have to have a witness because we need a tiebreaker for our cluster design. And for that, that's our next topic, the witness design. So we have again our picture from before. We have an active cluster. We have 2 nodes here and 2 nodes here. And we need a tiebreaker. So now let's have a witness, the green one here, inside 1. If we place our witness inside 1, we have now 5 votes. Yeah, and if now something happens to our side 2, we have now 3 votes from 5 votes. So in total it would be 5, but 2 are gone. So we have 3 from 5. That is more than half of the votes are available. So what will happen? The VMs, the volume will be brought up, the replicated volume will be brought up inside 1, the volume from side 2, and the VMs are started here. Everything is fine. So let's do the other side. Side 1 fails, and of course then our witness is also gone. So we have 2 nodes running inside 2. They are perfectly fine, but they have only 2 votes now from 5. So they are below half the votes. So they are in the minority. They are not at the majority, they are in the minority. So what do? They shut down the workloads they have. And we have no VMs running. But you build a stretched cluster to have all the VMs running in a disaster, not none running, because the cluster is in the minority. It will shut down the workloads. So how do we do that correctly? We have to place our witness in a third side. So, and what's very important, each side can communicate with the witness without the other side. So we have to have a direct connection from side 2 to the witness and also from side 1 to the witness, not going through side 1 to the witness. So if side 2 can only reach the witness through side 1 because all the internet connections are inside 1. That's not a design. You can't build a stretched cluster because if side 1 goes down, remember the slide before, your witness is also not reachable. It's running in your third side or in Azure, but you can't communicate with it, and that's like down, so the cluster will go down. So we have to have the witness in a separate side, and each side can communicate with it. Now side 2 fails, and what will happen? The cluster will bring online the VMs inside 1, and the other way around, it's the same. We have 3 from 5 votes, so still the majority, and our VMs will be brought up on the other side. So what witness options do we have with a stretched Azure Stack HCI cluster, or even with an Azure Stack HCI cluster? We have the same witness options with as we had in Storage Spaces Direct. We can choose a file share witness where we have a share somewhere. I think at least an SMB2 share, not SMB1, SMB2 share, or we can have the cloud witness We have another picture. Cloud Witness is an offering in Azure. You have a blob that is your Cloud Witness is very cheap. And I heard from a lot of customers in the past that have done or that are doing storage spaces direct. No Cloud Witness. We don't want to be connected to the cloud. With Azure Stack HCI, you have to be connected to the cloud because Azure Stack HCI has at least inform Azure every 30 days how much cores are running, because Azure Stack HCI is built through Azure. So you have to have a connection to the cloud, and then you can also use a Cloud Witness. If you don't have a third site handy with a file share witness, of course you can use a Cloud Witness, and usually it's much cheaper than to build a third site just for the witness. And what's not supported in Azure Stack HCI and Storage Spaces Direct, even if they are not stretched, is a disk witness. So in Azure Stack HCI, stretched or not stretched, and Storage Spaces Direct, only the file share witness and the Cloud Witness are supported, not a disk witness. So let's do a small demo how we install the Cloud Witness. Where is my? There it is. So I go to another node. Oh no, I do it here. The other already have a witness. So if we go to settings here, I'm now in an Azure Stack HCI cluster. It's installed. Yes, we talk questions at the end. That's very good. We talk about your questions at the end. So I have already installed it. It's registered in Azure. And now I go to the settings, and Manfred will show you how you register your Azure Stack HCI in the cloud, right? Okay. So if we go here in the settings of the Azure Stack HCI cluster, and we go to witness, you have the possibilities. We have no witness, or we could choose a Cloud Witness or a file share witness. I will add a file share witness, and then we have to give it a share. And here I have a share. We see there are already 2 clusters registers under this directory, under this share. And I will do now the third. So I go back here and paste it in and click on save. And now we have our witness set. And the witness, of course, has to be on a place, third site or in the cloud. So now our cluster has a witness. So if something fails, it has the possibility to have a quorum. We call it a quorum. A cluster has a quorum. He has more votes than the other side. And here you see it's all so registered in Azure, and Manfred will show that in the next session. So let's go back to my slides. This was a very small demo. So for the replication, for the stretched volumes, Microsoft use a feature that is available in Windows with Windows Server 2016. It's called Storage Replica. So you can use Storage Replica if you have a data center, Windows Server 2016, 2019, 2022, but it's included, of course, in Azure Stack HCI, the new operating system, and it's a feature for disaster recovery, so prevent you from disasters. So here we see where the storage replication is embedded in the I/O stream to the disk, or the I/O path from an application to a disk device. And it's agnostic to file system filters, to the file system we use, to snapshots, BitLocker, everything. In fact, it's between the volume manager and the partition manager. So in fact, we replicate partitions, not volumes. And here, every I/O to the disk is replicated to the destination site, and then also written to a disk. So it's very easy. It's block-based. Everything that is written to the volume, it's then transmitted over SMB3 to the other side. There are 3 scenarios we can do with Storage Replica. There is a server-to-server scenario. So if you have an Hyper-V server with a local volume, you can replicate it to another Hyper-V server. The volume would be offline. So if a disaster strikes here, you have to bring manually this volume online and register all the VMs that are in the volume, because this is not a cluster. Server 2 doesn't know about your VMs in that volume. He doesn't even know the volume. So this is a manual task. We have another scenario where we have 2 clusters using storage replica, and it's the same. We have 1 cluster here, 1 cluster here. If this volume fails, you have manually to bring up the volume and register the VMs in this cluster, because this is the second cluster and this is the first. This cluster doesn't know the roles. Only this scenario, and by the way, this you can do with Storage Bases Direct with 2 separate Storage Bases Direct clusters. But what we want is a stretch cluster where we have 1 cluster including both sides, and we have our volumes that are replicated. So if this side fails, the cluster already knows this volume and knows that he can bring it up, and he will bring it up automatically. And he also knows all the virtual machines, because this is the same cluster. He knows every node, knows every role and the status of every role. So he brings up the volume and he starts the roles automatically. So how does it work? The synchronous replication, we have 2 types of replication. We have the synchronous replication. We have an application, for example, our VM, that is writing a block to our source node. And in Azure Stack HCI, we have a source node and a destination node that is replicating the volume. So the application, the VM, writes a block to the source node, and the source node is writing the block into a separate log volume, also a CSV, and in the same time transporting the data to the destination node over SMB3. So SMB3 is used as a transport, and then it writes on the destination side also in a log volume, and then it acknowledged the write, the successful write of the data in a non-volatile volume. So the log volume is also on flash, and if you write it to the log volume, it's even if you have a power out of the server, the data is there, then the data is acknowledged, and then the application gets acknowledgement. So now the data is written, and of course, how long it takes from the write until the acknowledgement depends on how far away are the both servers. If they are next room, it's very fast. If there are 300 kilometers between the sites, you have maybe 20, 30 milliseconds of delay from your acknowledgement, and that's too much for a lot of applications. After the acknowledgement is done, the data is copied to the original destination. So as you see here, we have 4 volumes for a stretched data volume. So 4 volumes instead of 1 for a stretched volume. And we have some requirements. The latency between the sites should be below 5 milliseconds, and the log volumes have to be on flash storage. If we don't, if we can't promise these requirements, if the delay is longer than 5 milliseconds, or you have also the possibility to use asynchronous replication. How does that work? We have our application. It writes a block. The block is written to the log, and the write is acknowledged. And then the data is transferred to the destination node, written to the log, acknowledged, and then it is written to the data. But we don't wait on the other side. So the asynchronous replication is immediately, you don't have the delay, but you have also your data on the other side. It's not there immediately, but it's maybe a delay of 2 seconds or 30 seconds or whatever. So it's a continuous replication, but you don't have the guarantee that every write is on the other side. But it's also not bad, because if you have a disaster on the source side, you maybe are missing, let's say, 30 seconds of your data. That's much better than restoring a backup from the night that includes maybe, does not include 6-8 hours of data you have done, you have already changed in the VM. Okay, so let's create a stretched volume. Do a demo where we create a stretched volume. So we go to, we can do it here. We can go to volume in the Windows Admin Center. And you see we have already four volumes. And these volumes are the very important cluster performance history. So if you create a stretched cluster, where's my mouse here? Yeah, it's very small. So if you create an Azure Stack HCI cluster, a stretched one, you get your cluster performance history already stretched because it's important, and we don't want to miss all our data from all VMs, from all data, from all disks, from all volumes. So Microsoft creates a stretched volume. And here you see the four CSVs we get with that. So now we create a new stretched volume. I click on create, and here it will gather some information, and we have now the possibility to create a volume in a single site for my Exchange DAG or my SQL always on cluster. No, we want to create a replicated volume across two sites. And then we can specify where is it online, in west or east. So if it's in west, it will be created in west and replicated to east, or the other way around. So maybe if you create multiple volumes, you spread them over the sites for an active design. We just do it from east to west because east is first here. And then we can choose which replication mode. Do we want an asynchronous or asynchronous? And of course, you can change that later. So you can change from synchronous to asynchronous or from asynchronous to synchronous after the fact. So you can do that later. So I will call it stretched volume. And now we can choose the resiliency. And this is a 4-node cluster. So we have only the possibility to do a two-way mirror in each side. If you want to do something like a nested mirror or a nested resiliency, we have to do it in PowerShell. But for the demo here, we do a two-way mirror, and I say it's 400, not terabyte, it's a 400 gigabyte volume. So then we have some advanced options here, and you see our volume is called stretched volume, so it will create replication groups from the name with group and replication group and a log volume size. And best practice, it turned out at least do 100 gig or better 200 gig for your real world stretched volume. So the proposed 40 gigabits is much too less. So do 200 or even 500 gigabit if you have a 10 terabyte volume. And then we can do some other things here, but we can't do BitLocker and so on. And now I go to create. So I press create. What will the Windows Admin Center do now? It will first create the stretched volume inside east, then it will create the stretched volume log inside east, then it will create the stretched volume inside west, and this is offline, and it will create a stretched volume it will create a stretched volume replica in west, and it will create a stretched volume replica log in west, and that will take a bit. And it will also install a running storage replica. So we will come back to this one, and I will show you that in a demo, or I go to another cluster that is prepared for that. And if we look here and look under volumes, we have 8. Here you see we have our cluster performance history, our stretched volume log, and stretched volume replica and stretched volume replica log. And if we click on storage replica, we can look at the replication status of the storage replica partnership. And there should be one partnership for the cluster performance history and one partnership for our stretched volume. And it is continuous replicating. We can look into some details here. We see it's synchronous. Here it is synchronous. And we can, if we want to, can go to settings And here we can modify the partner settings, so we could switch it to asynchronous or from asynchronous to synchronous. We can increase the log size. It's a 200 gigabyte volume, so I would advise to do more here. Is it? No, it's, I think here it's only 100 gig. Okay, but I think you got the impression how it works. So let's go back to the presentation. I have still 10 minutes. Maybe I need a little bit more. So there are some PowerShell commandlets to help us with the replication. And to be honest, in the moment with Windows Admin Center, you can't delete a replicated volume, or at least you can't delete it fully. So you need some PowerShell commandlets, for example, to delete the partnership. Yeah, I hope it will be added in the Windows Admin Center module, but in the moment you need some PowerShell. And there are plenty of PowerShell commandlets. We have, for example, for the storage replica, we have a test SR topology where we can first test if a replication would work, especially in a stretched cluster that is a far distance stretched cluster. We can look at the replica status. There are replication groups. You can, with get storage replica groups, you can look at the status and see them, and there are the partnerships. So you can also get SR partnership, and there is a set and the new and the remove, of course. Then if your synchronization stopped for what reason ever, for example, your internet went down for 2 days, then of course your synchronization stopped because the logs are full and you maybe want to manually resync it. There is a PowerShell commandlet for that. Then a very important thing, you have to specify which network cards are used for the replications. Microsoft has some very strict requirements for the storage replication networks, and you have to for your storage replication groups, you have to specify which networks are used. Very important. Then we can delegate admin rights. So you don't have to be domain administrator if you want to care about the storage replication. There are possibilities to grant rights and revoke rights. And we can limit the bandwidth, how many bandwidth the storage replication can use in bytes per second. Usually we have to have a very fast replication network that you don't share with other stuff. So you don't have to limit the replication bandwidth. You have to guarantee that your replication can always happen. Otherwise you have some problems. So let's move a VM and a volume to show you. That was a question when I first introduced stretch cluster before it was available. We knew last year that the stretch cluster scenario will be available, and people ask me in webinars, can you move a VM around without a fail? Yes, you can do that, and I want to show you that. So I go back to the demo. Here in this cluster, we have a running replication, and I have deployed one small benchmark VM into this stretched volume. So if we look in the Hyper-V settings here, and you see we have it in the stretched volume. There are our disks, yeah, in C cluster storage, stretched volume, small benchmark. And now I saw I missed something. I didn't include the VM in the cluster. I will add that. So I have to connect to the cluster. I'm on 2. The cluster is called Azure HCI 2 cluster. So this is live. And I open the cluster. The good thing is all the old tooling is still working. And if I go to roles, there is nothing. And I will configure a role. Just a virtual machine. The cluster will look on the hypervisors, which roles are not included in the cluster yet. So I add the small benchmark VM, and then we have it in the cluster. So here we are. It's running on the first node. You see that here. And our stretched cluster, going to Windows Admin Center to show you, clicked wrong, to show you the servers, and under servers we should see under inventory where each node is. So we have an east and the west side. No, we can't see that here, right? So we go to Windows Admin Center under nodes. Here are the sides. So the first node and the second node are in east, and the third and the fourth node are in west. So our VM is running on node 1 in east in the volume called stretched volume. And stretched volume is also the owner is the node 1 where also the VM is running. So now I want to move the VM to the other side. So let's do a live migration here. Move, live migrate, and select. So if I choose best possible node, it will move it automatically to node 2 because it's in the same site. And if I then again live migrate and let him choose where to move, it will move it back to 1. So the VM will stay in the same site where the storage is. And if you let a VM move it to the other side, that's now the case. I have now running the VM on in the other side. The cluster will move it back to the site where the storage is. So the VM is following the storage. After a while, it will move it back automatically. So now we have the VM running inside west, and the storage is inside east. And we can see that if we look at storage replica here, it's much easier. I like the Windows Admin Center, and I always use Windows Admin Center unless I don't have the feature I need, like moving a VM on purpose. You can't do that in Windows Admin Center in a cluster in the moment. So here you see we have our replication from node 1 to node 3. And now I click here. Let's see what happened with the VM. It's now running on the other side. And I say here, switch directions, and maybe he asked me for something. So here we see the VM. It's switching directions, and we will see two things. The I/O will halt on a hardware cluster. This is a virtual machine cluster on a hardware cluster for 5 to 6 seconds. Then we'll have I/O again. Here it maybe takes longer because this is a nested virtualization cluster. Then the I/O will be there again, and then it will halt for another 5 to 6 seconds. Here, unfortunately, it takes longer. But in real world, I've done this multiple times. So you will have an I/O hold for 5 to 6 seconds and another one, but your VM is running. Here you see the another one. But after, let's say, 30 seconds, your VM, the storage is on the other side. You have two small 5 to 6 second I/O pauses, and then the VM is running on the other side. And now it will rebuild the replication. Yeah. So replicating some blocks back to the other side. Okay, let's go on. I'm nearly done. So with the time at least. So now some important network requirements. And Microsoft was a little bit late to document the network requirements for a stretched cluster. So in the site, so here we see an 8-node stretch cluster, 4 nodes inside A, 4 nodes inside B. In the sites, you can do SMB3 over SMB direct, so with RDMA for the storage replication between, not storage replications, excuse me, for the software bus layer, so the storage bus, when you have your extends, your VM writes into extend, and you have a 3-way mirror, the data must be written also to other nodes. For that, we use SMB direct preferably. Switchless is also supported in the site, so you can connect the 4 nodes with a lot of cables without switches. So for the replication network between the sites, we need a fast, low latency network. That's important. Low latency, because if you do synchronous replication and you have a high latency network, it adds to your I/O because it adds the milliseconds to the I/O. Microsoft does not support RDMA for the replication traffic. Indeed, Microsoft wants to have separate adapters for the replication traffic with no other traffic on them. Yeah, I have some support cases where that is clarified, no other traffic than the replication traffic on those adapters. And only SMB over TCP/IP. And we have to have layer 3 routing. Microsoft does not support a layer 2 IP network between the sites, even if there's only one small wall between the two sites, and you can perfectly have a layer 2 network. Microsoft requires a routing instance, so you have to have routing in your switches or in your firewall for the replication traffic. It's not supported to have a layer 2 network. No layer 2 network is supported. I'm talking to Microsoft because in a small stretch cluster with small distances, it would be much easier to have a layer 2 IP network instead of doing routing in switches and so on. And we have to add our constraint network, so the storage replica constraint network for the replication group. Otherwise, the network is going over another net, and it does not prefer the routed networks. Usually it uses the management network or so. You want to have your replication traffic on the separate networks. That's very important. I will maybe do another webinar about that because I'm doing in the moment, I've done the last months some stretch clusters. What about ... in stretch cluster? Azure Kubernetes services. In the moment, Azure Kubernetes services are not supported in a stretch cluster scenario. And that's a huge miss in the moment because if we do Azure Kubernetes services on Azure Stack HCI, people want to stretch them. They want to have high availability or even disaster recovery possibilities for the containers. Software-defined networking doesn't work, it's not supported in a stretch cluster scenario. It's only supported in a non-stretched cluster scenario. BitLocker, it works. So I have a customer where I implemented BitLocker on the stretched volumes, but you have to do it by hand. So with PowerShell and some commands you have to do on the host. In a remote desktop session on the host. It is not working remotely where you use invoke command or something. Integrity checksums. I don't know, actually. I have some questions for the product group. Integrity checksums, you can't configure them for the data part of your stretched volume. So there's no, in Admin Center, there's no possibility for that. Manfred will show you that you can do that very nicely, BitLocker and integrity checksums, if you create a volume in a not stretched scenario. Deduplication, same. I don't know if it's supported. At least you can't configure it with Windows Admin Center. But in the moment, I would say don't use deduplication. So now disaster demo we skip. I will, because we have only some minutes left. And are there questions?
A lot of questions.
Okay, then we go to the...
A lot of questions. Helmut did a great job. He already answered a lot of them, but maybe it's interesting to take them, or some of them on audio. Yeah.
So ask away.
Okay.
We have, let's say, 6-7 minutes, and then
Okay, so let's see which questions we have here, where we will start. So there are some questions about Windows Admin Center. I will take them in the next session.
Yes.
I think this is a good idea, so we don't forget them. There are comments about Windows Admin Center. We will take them later, so you can sure we have them here. So there was a question when you were presenting, Carsten, can we change the resiliency from two-way to three-way mirror?
That's a great one, and thank you for that question. And it's so the technical answer, or the marketing answer would be yes. You can not change, but you can go from a two-way mirror to a three-way mirror. But if you want a technical answer, not really. So how do you change from a two-way to a three-way mirror. There is no built-in possibility to do that with Windows Admin Center or even with PowerShell. But you can, of course, create a new three-way mirror stretched volume, or even if you don't have a stretched scenario, it's also not possible. But you can create, if you have space, a new three-way stretched or not stretched volume. Then you move with storage migration your workload from the two-way mirror to the three-way mirror, and then you can delete your two-way mirror. So that's a workaround that can help you, but Microsoft has no possibility yet, and maybe it's a feature that will come in the future, but in the moment you can't do an upgrade of a two-way mirror to a three-way mirror. So if you add nodes and you have a four-node cluster and you have a two-way mirror, the volumes, if you extend them, and even extending a volume, I haven't managed to extend a stretched volume so far, even not with PowerShell. I was not able. So, but if you could do that, it would still be a two-way mirror. So you have three nodes with two-way mirror, and you have to create new ones. So unfortunately, no. Long answer for no.
Yes. The next one, logs on flash. Is that a dedicated drives or can the cache drives be used?
No, you can't use the cache drives. If you look at Azure Stack HCI, there are different possibilities. So if you have more than 2 tiers, so for example, SSDs and NVMEs, or HDDs and SSDs, the SSDs can't be used for the flash. You have to have separate flash drives. So you can't use HDDs for your storage replica, or you can use them because the cache is used in front of it and you have a fast write. So I would say, yes, you can use them, but Microsoft is not clear about that. The requirements for storage replica are old. They are from 2016, and I haven't seen Microsoft change them. So yes, you can use HDDs with caching devices, and every write is going to the cache device. So it's fast, so you can use them. Yes.
Yes. Okay, so then I didn't catch this in your presentation. Here's a question, 4-node switchless. Carsten mentioned 4-node switchless, but aren't only 3 nodes supported? No, you can also build 4 nodes.
Yeah, Microsoft at Ignite 2019, there was no talk about Azure Stack HCI so fast. It was still all about storage bases direct. Microsoft on Ignite 2019 said in a session, we also support not only 2-node, that was supported forever. We support 3-node, we support 4-node, and we support 5-node switchless. You have a humongous amount of cables behind your servers if you want to do it redundant. And I assume that it's also supported for Azure Stack HCI, but in the docs, there is switchless stated. Yeah. Mm-hmm. But we have really to ask Microsoft about a support statement for a stretched cluster, but it works technology and technology-wise it works, but we don't have a support statement, I think.
I says Dell supports 4-node switchless.
Yeah, but if Microsoft is not supported for nodes, Jaromir, you are not allowed to use more than 2 RDMA cards or 2 cards in a cluster, so it would be only 1 port to the nodes, right? I want to have 2 ports between the nodes. So if you have 4-node switchless, you have to have 6 ports in every server for the switchless, and then add more cards. But this is a complete different topic. Maybe we can talk it later on the Q&A, maybe, or not the Q&A, the roundtable.
The roundtable, yeah, we can take this one to the roundtable. Yeah. This is a good topic because
do we have more?
Yeah, we have more. We have one. I think the question is not correct here. The question is, what is the minimum number of nodes failure we can tolerate in 16-node cluster? I think it must be, what is the maximum number of nodes?
Yeah, so in a 16-node cluster, if it's not stretched, 2 nodes can fail, not 3. To be honest, you can have failures in 2 fault domains, not in 3. So even 3 disks in different nodes is a disaster. There are things to mitigate that, fast parallel rebuild and so on. But in a non-stretched cluster, 16 nodes, only 2 nodes, 2 fault domains can have failures. If you have a stretched cluster, 2 60 nodes stretched, you have 8 nodes on each side. 2 nodes can have failures in one side. So you have 8 nodes in one side. 2 of them can have failures. If 3 fault domains have failures, you switch over to your other side. Yeah. So in a stretched cluster, you can have more failure than in a non-stretched cluster. But in essence, I would not build a 60-node cluster. Period.
Perfect. So one is here, layer 2 for stretched VMs is supported, question mark?
What do you mean with layer 2 for stretched VMs? For the replication traffic, no layer 2 is supported, only routing, layer 3. Stretched VMs, you have to clarify what you mean, but Azure Stack HCI is always a cluster with VMs. There's no other supported scenario like file server or so, like converged. It's always a cluster with VMs. So layer 2 for the replication traffic is not supported. You can have layer 2 for your VM communication, of course, but not for the replication traffic.
Yeah. I think you had the information in your presentation. TCP/IP generates a lot of CPU overhead on Hyper-V hosts, on fast networks, 100 gigabit and above. So is there RDMA support for replication traffic on the roadmap?
No.
Oh, the question is on the roadmap. So actually it's not there?
No, so let me phrase it differently. So far, I had talks with Microsoft, especially about the replication traffic, because of course, in the first projects I've done, I'd used RDMA in a cluster scenario on a campus where the clusters are only 100 meters apart or so. We used RDMA for that. It's not supported. Microsoft's statement in the moment is RDMA is only supported in one rack. If you leave the rack, it's not supported. Yeah, so I don't think that we will ever get RDMA supported for the replication traffic. And to be honest, usually you don't have the churn of where you need 100 gigabit in a cluster. Yeah, it's a lot of data that has to be written. So the block is only transferred 1, not 3 times. Yeah? So unfortunately, no RDMA support so far for replication traffic, and I don't see Microsoft change that in the near future, at least.
Okay. Do we have time for some additional questions?
Yes.
Should we?
You have the next session, so if you want to, we can still do 3 minutes.
Yeah, okay. So Helmut, I mentioned this already, answered some questions in the chat. We will also answer additional questions after this Q&A. There's a Q&A after each session, and if you cannot take all the questions here via audio, we will try to do it in the chat. We have one here. In a scalable architecture, can we upgrade from 2 nodes cluster to 3 nodes without rebuilding the cluster? I think it's not related to stretched, it's related to.
So let's say that you can add nodes to an Azure Stack HCI cluster from 2 to 3, from 3 to 4, and so on. If you have a stretched cluster, you have at least 4 nodes, so 2 at each side. You can also add 1 node on each side. You can do that. You don't have to rebuild the cluster. Your data is still there. It will be spread over all nodes. That's perfect, but it will not change the resiliency of your volumes. So there was a question before that. If you want to do that, you have to create a new volume and move your data.
Yes, okay. I think these were most of the questions. Didier had a comment about this RDMA topic, but I think we should discuss this later and maybe take it to the round table also.
Okay. Yeah, thanks so far for watching. At least let me do one small addition before you start. My company, the Rachfahl IT Solution, is implementing and doing trainings about Azure Stack HCI, but also Storage Bases Direct and Hyper-V. So if you need maybe help with an implementation, you find us under rachfahl.de. So Rachfahl is my last name.